Good day, everyone. I'm Fernando, and I lead the cloud storage organization at Atlassian. We are responsible for providing secure, reliable, and efficient storage solutions for all of Atlassian and its customers. And today, I am here to share with you some of the learnings of operating OpenSearch at Atlassian scale. But first, let me tell you a bit more about how search is used across Atlassian. OpenSearch is so flexible that it allows us to power many different scenarios, ranging from internal operations to serving our millions of users worldwide. For example, we use OpenSearch for storing high-volume operational data. We translate GraphQL to OpenSearch queries to power different internal business use cases. On the other hand, we also use OpenSearch to power critical customer scenarios. User and team search, as well as pickers, recommendations, and invites across all of our products are powered by the same service relying on OpenSearch. We built a user search service specifically to standardize how all of these experiences function and to meet regulatory compliance requirements. Has anyone in here used Jira? Awesome. Well, historically, Jira search, when you look for an issue in Jira, that has been powered by Postgres full text search. But recently, we moved to OpenSearch. Now, Jira query language processing is powered by OpenSearch, and we've seen massive scalability and performance improvements with this. But it came with a cost. Jira was built on read after write assumptions, and so it required a lot of engineering effort to move to an eventual consistency model that OpenSearch provides. But it's been well worth it. And last but not least, Rovo, your AI teammate, is powered by OpenSearch. Rovo really pushes the boundaries of OpenSearch by leveraging semantic, lexical, and structured search capabilities depending on the user's queries. We recently announced at Team 25 our Rovo for All initiative, bringing the power of Rovo to all of our customers. We are so excited about Rovo that I have to tell you a little bit more about it, so bear with me for a second. Rovo provides enterprise-grade search for all of your Atlassian data and more, with over 50 connectors currently available for third-party tools, and we expect this number to grow. Rovo Chat brings conversational AI capabilities to all of your enterprise data. And with Rovo Studio, we allow our users to build and deploy their own AI agents and automation. And to sum this all up, our engineering team brought Rovo in just 6 months. And semantic search has played a key role in powering all of these scenarios. And Rovo for All means that all of our customers get access to these capabilities. And that's a significant increase in scale, and scale really complicates things. So let me put some of the scale numbers that we see at Atlassian into perspective. We serve over 300,000 customers. And we power over 1.5 million monthly active users for AI. And this is across 13 regions worldwide. How do these numbers translate to OpenSearch? Well, we operate more than 300 clusters. And in total, we have over 2,000 data nodes. And our largest cluster holds over 23 billion user-generated documents. At our scale, we see some significant challenges. Multi-tenancy is essential for running cloud services at big scale and efficiency. But unfortunately, OpenSearch is not that great for multi-tenancy. One of the challenges comes from how shared information is kept in memory and is replicated to every node. Modeling at tenant per index would end up with too many shards in a single cluster, and we would hit some serious scalability issues. So we use a single index with custom routing to map between tenants and shards to work around some of these scale limitations. But this solution comes at a cost. it's fairly complicated. For instance, once we retrieve the results from the index, we need to perform tenant-level filtering, which negatively impacts our semantic search recall and overall query latency. Another effect of this custom implementation is that this route is on the shard construct, but we are hosted on AWS OpenSearch, which only exposes cluster and node-level metrics. This presents some serious operational challenges for us, as we don't have the right visibility at customer level, and being unable to derive metrics at per tenant limits our ability to optimize our service and inform some product-level decisions. You know, earlier in my career, I had a manager who'd always say, Fernando, every challenge is an opportunity. That was, frankly, a little bit annoying, but it was really good advice, so it stuck with me. So I guess it's been very effective. So let me tell you about some of the ways in how we tackle some of these opportunities. Even before Row for All was a reality, search cluster demand was rising significantly, and it was only accelerated by our customer-managed encryption keys offering, which requires an expensive cluster-per-customer model. As up until recently, we had no way to provide index-level encryption on top of AWS OpenSearch. OpenSearch cluster management has also been historically a very high-touch affair for us. In a non-linear manner, or risk overwhelming the engineering team with too much operational work. So we built a control plane to orchestrate configuration changes and for both clusters and indexes. This control plane also allows us to manage enterprise data flows like encryption at rest and data residency guarantees. In addition to the control plane, we also had to invest some serious effort into observability and change management capabilities so that we could drive standardization across the fleet. Avoiding infrastructure differentiation is essential to scaling efficiently and reducing complexity. But scaling has also required a significant cultural change. Historically at Atlassian, we've operated under a you build it, you run it philosophy, right? It's very powerful. Each team is responsible for operating the services that they build. This comes with a high degree of autonomy and allows our teams to move very quickly. But as a side effect, we've also seen duplication of effort and sometimes different consistency across the teams, needing to make different investments to tackle some of the compliance requirements. So Atlassian is now very focused on the enterprise market, and it has become apparent that platform leverage and centralized infrastructure management is essential for meeting our security, reliability, and compliance requirements that our enterprise customers require. Don't get me wrong. We still believe that you build it, you run it is the right model, right? But not when it comes to infrastructure. By consolidating the expertise, we are able to create economies of scale and improve the reliability and efficiency of our search infrastructure. But there's more challenges. Our business is quite demanding. It's ever evolving and growing rapidly, and we need to keep up. And don't get me wrong, that's a great problem to have. But we need to constantly balance new feature deliveries with operating the service and paying off technical debt. As demand grows, building and configuring new clusters can become a time-consuming and expensive operation. AI also presents a very unique opportunity that we are trying to capitalize on. Yes, we shipped Rovo for All in just 6 months, but we need to keep iterating, and we need to deliver more value to our customers. And sometimes there is friction across the system, across multiple layers of the system, that slows us down. Tech debt, platform gaps, or unforeseen issues. And being on a managed service has meant that we are subject to someone else's priorities and release schedule. And sometimes we just end up waiting for longer than we would want for features and bug fixes. So finally, being a platform team ourselves, we have to support multiple customers with different versions, topologies, and configuration settings, which significantly increase our complexity matrix. When we looked at our scale, we thought, what if we did it for ourselves? What would it take for us to build our own infrastructure? So we did a quick prototype to validate our theory, and the results were quite positive. We were very bullish, and we wanted to move fast. And lucky for us, this community has built some really powerful and robust software, and we're able to stand on the shoulders of giants. We chose Kubernetes to orchestrate OpenSearch, and so we could leverage the rich ecosystem and community. And the bet has paid off. We use Cargo and Argo CD for progressive rollouts, and Carpenter for node management. For our observability stack, we use Prometheus and OpenTelemetry, mixed in with some proprietary technologies. And less than a year after we started our journey, I'm happy to say that we are already in production. In fact, if you search on Jira, you're probably using our service. We knew that our fundamentals had to be rock solid. Enterprise-grade reliability, security, and performance were all designed into the system from the ground up. We focused our efforts on Atlassian-specific needs. We reduced complexity by targeting only a subset of versions. And going from a black box to an open platform has really allowed us to optimize how we build our products and features and get the most out of OpenSearch. In fact, this flexibility has already allowed us to build some tailored solutions and addressing some of the gaps we talked about earlier, like the shard level observability. Our ultimate goal has been to increase the agility of Atlassian, wanting to run more AI experiments in parallel to refine our models and experiences and provide more value to our customers. We also wanted to bring platform updates faster and align with our business needs. And we're already seeing the benefits. Our AI experimentation team, which was an early adopter, has been able to iterate faster. And we're also being able to bring in fixes to core plugins and resolve long-standing reliability issues. Our team has achieved some significant results in a short period of time by really focusing on our customers' needs. But there's an additional dimension that I think is very specific and very important at Atlassian, which is developer joy. We have the same level of commitment we have to our customers as to our internal developers. We want our engineers to have the best tools possible so that building our products can be a fulfilling and rewarding experience. And this philosophy requires a little bit of extra effort, but I think it's very well worth it in the long run. It's been a really fast-paced 12 months for us, and we've learned so much through this journey. So let me try to summarize it. It's probably obvious for you a lot, but running stateful services on Kubernetes is not straightforward. Pods come and go. Our nodes are periodically restarted for security patching, and we have little to no control over these events. We designed our system to leverage availability zones for resilience, but that wasn't enough. We quickly had to learn the ins and outs of stateful sets to really fine-tune how the system deals with these failures. For instance, we get much faster provisioning times and recovery by pre-creating volumes in the desired availability zones instead of blindly relying on the stateful sets topology constraints. It's been tough to get reliability and stability. There are so many knobs to configure and so much complexity around shards and indexes and segments that making seemingly simple changes can have an impact to cluster reliability. And while the control plane for OpenSearch is fairly robust, we've seen that some failures can overwhelm the cluster and bring it down. So it is extremely important to understand the scaling limits of the cluster and avoid exceeding them. We think that automation is essential to operating a large fleet. Finally, we also learned some early lessons on how critical it is to have the right observability. Monitoring too many signals can bring the cluster down, but not monitoring enough means that we make our troubleshooting much more challenging. Node level metrics, for instance, can be collected every minute, but cluster and index level metrics require cross-node communication. So it's best to use an outside collector and not log any more than 5 minutes at a time. So we've had some early successes in reducing incidents by building activity correlations and a recommendation engine to prevent issues. And we've been able to move quite fast because of this great community. The tooling is awesome, and there are so many lots of great resources to learn and build upon. So we're very grateful. Operating OpenSearch at Atlassian scale is impossible alone. We are excited to be part of this community, to share our learnings and tackle common problems together and unleash the potential of every team. Our journey is only starting. There are plenty of opportunities ahead of us. So I hope you enjoyed this talk. I'm going to be available at the booth in case you want to come say hi or ask any questions. Thank you all for listening.